चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग टाइम. इन दिस वीडियो we will see how to configure monitor session and how we can do the capture analysis with the help of Wireshark. So this is the topology we have, and here I have mentioned the command to capture a Wireshark capture on the router. Okay, so this command is not same for the whole platform. The Cisco command line can be changed. Okay, so this is the normally we configure monitor session number, and then after that we configure the source interface from this interface traffic I want to capture, and destination interface where you will connect your device either with server or laptop, anything. On that device you run the application Wireshark, and after that you do the analysis. So here we are trying to capture a packet on the router 4, and source interface the traffic which is coming from router 3. So with the router 3, this interface connected, interface number is ETA0/0. So this interface become the source interface, and destination interface where the laptop is connected, ETA0/2. I mentioned the destination interface, and I have enabled the. By doing this in the Wireshark, when you run the Wireshark capture on this ETH0 interface, so you will be able to see that you are seeing the capturing the packet in the Wireshark application. So let's suppose someone have shared the Wireshark capture file to you for the analysis. So first question can be where these capture are taken place. Okay. So in some cases, or you can say most of the cases, it's matter where the Wireshark capture are taken in the network. Okay, like in this topology, we have a topology. We are sending a traffic from router 1 to router 6. Okay, so this is the source and this is the destination. Normally, capture are taken near to the source or destination. So one question can be, how will you find out that where those capture are taken if someone have shared the Wireshark file to you? Okay, so I am running the capture file. Okay, so this is the way you can do that. Let's go to the Wireshark capture. So this is the Wireshark capture file we have. So let's find out how we can check from where this capture is taken, from which host. So let's suppose we have a source and destination IP. So let me put filter for the IP dot addr is equal to 1.1.1, and IP dot a IP dot a ADDR, sorry, I'm telling the AP, it's IP ADDR is equal to 1.1.1, and IP dot ADDR is equal to 6.6. These are the two IP involved. So here we have here in this field you can see here we have this column time to live is showing the 253 when packet is coming from 1.1 going toward the 6.6. So this means this capture is taken 2 hop away from the source. As original packet ICMP TTL will be 255. So TTL got decremented value 2, the 255 minus 2. So rest the 253 is still in the packet. And similar way, when ICMP reply is coming, that TTL value is also 253. This means that destination is also 2 hop away. So in the middle of the topology, this capture is taken. This is the one way we can verify. And second thing is with the help of this L2 header, as we know on every L3 hop, L2 header will be rewrite, so source and destination MAC will be changed. So these MAC addresses in the 30 and 40 will be the link MAC address from where this capture is taken. So title was saying that title was showing the 253. So mean the 2 hop away. So means 1, 2. This means that on this router 3, on this link capture are taken. Okay. And similar way from the response on the ICMP reply also title was the 253. So 25 for this packet, this router will send the reply with the 255. And when this router will proceed further, so this will decrement the TTL with the 1. Okay, that 254, and that will become the here. It will further, it will forward the packet, it will decrement again TTL. So on this link we are capturing the packet, and so we are getting the TTL value is 253. Okay, 1 2 hop packet travel to the 2 hop. This have sent 1 2, and And similar way from this here 1 to 2, so 255 minus 2, so 253 is the TTL value. So this is the link where the capture are taken between the router 3 and router 4. Let's verify with respect to MAC address also. With all these hops are all these router L3. So on every router, uh, when the packet will forward, so L2 header will be rewrite. So MAC address should be uh, this source MAC address should be router 3 interface. Destination MAC should be router 4 interface IP. Source on the R4 MAC should be 40. Show interface number is same on both sides of the router R3 and R4. 0. Sorry, show interface ES0/0. Here we go. Here it's showing the MAC address AA BB CC.00 40.00. We are on the router 3. Our source MAC was AA BBC 30. Okay, so let's verify this. And in the topology interface, we have seen that that was the ETH0/0 on both sides. Show interface ETH0/0. Here, if you see AA BBCC0 30.00. So this is the MAC address we have seen. Okay. Similar way, let's verify for the R4. So in the Wireshark, we have an anomaly. We can put the filter with the help of protocol name itself. Like if you want to look only for the OSPF packet, the name OSPF. So this we apply the filter for the OSPF to see so the all of the packet related to OSPF. Similar way, if I want to see the IP packet, I can put the IP. Okay, this will show the all of the IP packets is there. Similar way, if I want to go for the R packet, this will the there is no R packet in this. The UDP packet if I want to show, this is the UDP. If I want to check the TCP packet, okay, so this will show the whatever the TCP packet in this. And if I want to show the ICMP packet, this will show the ICMP packet. Okay, this will show the this way we can apply the simple filter to check the packet. And below downside we can check in the watch how many IC packet are there. There's no need to count it. So this is where you can see that displayed. If you see here, let me see if I increase the size for this. No. So here in the downside in the packets, total packet in this capture is 128, but displayed packet is 10. So this means the ICMP packets are 10. If we see for the OSPF, how many packets, what is the count of the packet in the capture with respect to only OSPF? You have in the downside displayed, filter got applied, 56 packets are related to the OSPF. And we can use the and or operator also. Like I want to capture a packet not OSPF, I can simply write. So this will filter all the packets related to the OSPF. Similar way, ICMP not. Okay. Or you can pass the exclamation sign and then after that you can put OSPF. So this will filter all of the OSPF packet from the Wireshark capture. So this is how it will show in the video. It's not showing. So when you put the filter for the any protocol, so this will display like for the OSPF it was showing the 72 packets. Total packet is 128 and only filtered packet is 72. Like for the different protocol, you can see how many packets are there. Here are the few more filter we can see. Like for this, every protocol has some flag, correct? Like on the TCP, if we do that in the Wireshark, after putting the TCP, put the dot, so it will show the option. TCP stream, TCP analysis, TCP flags, everything it will show. So with the help here this, we can get what other filters are applicable with the TCP. Like go for the TCP flags. Okay, TCP flags. In here, the flags we have now. We know there are multiple flags like sync, synac, reset. Okay, let's go for the syn. Okay, and syn flag is equal to one. So let me put filter here, where we can see that we apply the below TCP dot flags in dot 11 And I also want that suppose for the ACK flag also should be one TCP again TCP dot flags. Okay, dot ACK acknowledgement flag is equal to. So these are the successful where we can say that three connection got complete in the TCP. Okay, so in the downside again we can see the display packet is three. Okay, so these are the similar way for the other packet also, like for the IP also. If we don't remember the filter IP after that dot, it's starting showing the options IP dot ADDR. Okay, so IP dot destination host, IP dot flags. So multiple options we can do with that. And similar way for the like for the DNS. The DNS also we have a flags. Okay, let's put the filter for the DNS packet here. Here we have a few DNS packet. So this is the query, DNS query for this. Here we can let's look for this packet. Okay, selected. I have selected the packet number 59 here. So this is the source IP 192.168.1.1 and destination 6.6.6. This is the DNS server. IP is 6.6.6. As we can verify with the help of destination port also. Port is 53. This is the DNS packet. Okay, and source port is 55773. Okay, and here is showing the standard query. If you select the packet, if you go down here, it's showing the this is the query message where the response flag is 0. Okay, so we can put the filter with respect like this DNS dot. If we do the flags, it is showing the response is equal to 0. Where we can these are the messages which sent by this host to this DNS server 6.6.6 but didn't receive. So these are the you can say these are the query message. These are the query message sent. Okay, and if I look for the response, in the response flag will be 1. Okay, so these are the two responses got from the DNS server. Okay, here is DNS server sending the response for this. A record is there, R2 and R3. Here we can see that if we go down here, this is here for the router 2 and answer. If you go to the answer, here it's showing the for router 2 IP address is 2.2.2, and similar way for the router 3 DNS is sending A record 3.3. This IP address is sending. So, and this is done, and we can also check conversation also. So let's put the filter for the telnet. So this is the traffic related to the telnet from this host. This we are trying to telnet this destination 192.168.1.1 is our source IP and this is the destination IP. And if we follow this, if we do the right click and follow this TCP stream here, follow, you can apply complex filter like this way. Like here we have in the I select this packet, any packet. So here, let's say we want to put a filter for the source port 23 and we don't know the filter name, how to define a filter. So what we have to do, just drag and drop here in the filter bar, in the content filter bar. We select OK. So I so this have automatically populated the filter TCP dot source port is equal to 23. What are the packet? Here have a source packet, source port with 23. That will be. Let's say we also want a packet who have an acknowledgement flag is set. So here I go to the flag. This is when it's showing acknowledgement. I'm again putting this drag and drop here. I'm putting it, and this will show the option. This is selected, not selected, and selected. So let's say and selected. TCP port source port should be 23, and TCP flag should be acknowledgement should be 1. Let's say we want to set the TCP SYN flag also. Let's find the packet here. Here we have this SYN packet. Let me select it. Here the SYN flag is also selected. So let me again drag and drop here. Filter I say and selected. So this way we applied a TCP source port 23 and TCP and this. So these three filter got placed, and if you follow any of the TCP stream now, okay, ultimately to get the successful TCP handshake after that this will work. So let me do that, follow TCP stream here, and to find out the connection, how many connection in the pack in the in the capture for the TCP, UDP, and where the high volume of data is exchanged. So you can go to the into the Wireshark in the statics. Under that conversation, if we go, this window will pop up. Here you can see that in the TCP it's showing that there were the 34, 35 connections, and these were the port A, these were the source port and destination port, and these are the bytes. If you click on the bytes, so here is showing the between this host on this port 46029 and destination port 23,117 packet got exchanged, and this is the 6.449 byte of data is showing. Okay, a similar way for the UDP also it's showing the four packets. The whole packet at DNS at the destination port is 53, and here also you can similarly check whether how much data is exchanged between these points with on this source port and destination port. So these are the 35 connections on the unique port. The source and destination port are different. Okay, so this is how you can check detail with respect to how many IP4 in there. Okay, how many TCP connection got TCP connection TCP packets are there. Okay, similar for the UDP. So once you do the right click on the packet and for the TCP stream, this window will pop up, and here you can see that how we can check user and password. In the case of Telnet, password user to connect to the router. You can also search for the string in the capture, and there are the two filter. We can use the frame contains and frame matches. Frame contains a case sensitive, so string should match exactly, and the frame matches we can pass any character like this way frame, and then contains that the contains here after in the double quotes you have to pass the string, but string should match. This is the case sensitive. Let's put the Cisco here. So this will search the string Cisco. Anywhere found it will display. Similar way for the matches is not case sensitive and matches. Okay. And again in double quotes we need to pass a string, like pass the string test. So this will show. If I increase the cache, it will still show. Okay. A similar way, if we want to filter a capture for a specific port number, so we can use a TCP dot port. Okay. In operator we can use after the curly brackets. We can put the multiple port number. Like I want to see the traffic from the port number 22 and 23. I put the 22, comma 23. Enter. So this will show on the packet which have 22 or 23. Similarly, we can put the range also in the curly brackets. Like I want to see packet from 1 to dot dot, then I will put the 1000. So port number 1 to 1000 will show all of the packets. So this way you can use the in operator also, the TCP dot port. So we have one more case here. I am on the router 1 and we are trying to telnet this router 6 from this router 1, and somehow let's see this telnet is not working. Okay. So let's capture the packet and we'll see. Okay, so this is where we are capturing the file. Let me stop the capture. While you know telnet work on the TCP, let's put the filter for the TCP here first. Put the filter for the TCP. Okay, once I put the filter for the TCP, I can see that this is my source address of the router 1, 192.168.1.1, and this is the destination IP 6.6.6 is going for the TCP connection on the port number. With the help of port number, we can easily identify this. This is the telnet connection port 23, the destination port, and source port is 3954. Now, for this port, we need to find out what is the response packet. In the bigger file, it's might be difficult, correct? It will be difficult to find out what the response packet. So here, this is the frame number 10, this is the 11 number, but in the actual, you will not find the packets in sequence. But how you can find out that? So first thing in this packet, first packet we need to notice that our source port number was the 39547 and 23 is the destination. And here in this capture, this is the response, okay, which is coming from the server saying the destination unreachable. And if we go downside under the TCP packet, again we have our source packet which was sent. Okay, here you can see that this TCP packet was sent where is mentioned this is the source packet, source port number 39547 is matching exactly with this first packet, and this is the destination port, and this is the source IP and destination IP. For this, it's sending the destination unreachable. And here you will see in the code, communication is administratively filtered. So it means that something ACL something is configured, and this is the reason Wireshark is displaying this way. And if we see that what is the source IP, this router is sending this message, communication is administratively filtered. So we need to find out that this source IP who is sending this message. Okay, 194.168.1.2. Okay, let's go to the topology. So here we are on the topology from the 194.168.1.2. We were getting the response filter is administrative filtered. So there is some problem on the router 4 in configuration. Okay, let's go to the router 4 configuration. So here we are on the router 4 configuration. If we check interface something like the interface coming from the R3, okay, on Ethernet 0/1. No, this is an interface. This 0 should be there. Okay. Here this ACL is applied. If we check for the ACL, show IP access list. So ACL is here. This is denying the all the TCP traffic and only permit ICFP traffic is there. So this is the region our telnet connection is failed, and we have seen the Wireshark displaying this is filtered by the admin. So when we capture a packet in the Wireshark, so for the TCP different flags, these are the value will be shown in the Wireshark. For the SYN will be value 1, for the SYN-ACK value will be 2, for ACK 4, acknowledge, for data 8, for FIN 16 and 32, for the reset flag. So based on these flags and addition, we can filter. Like for the TCP completeness, if you want to filter the packet whose are the flags set SYN and SYN-ACK, we can do the TCP filter TCP dot completeness is equal to 3. In our case, as we are trying to do the telnet from the router 1 to router 2, we will do the telnet, and after that we will disconnect the session. Okay. So total completeness field value will be 31. Like finish for the for fin flag 16 value, for data 8, acknowledgement 4, and CNAC 2 and 1. So this all flag will be coming to the picture in the full successful connection. So 16 plus 8 24, 24 plus 4 28, and plus 3 31. Let's put the filter with the 31 value. So filter is TCP dot completeness. Okay, and it's equal to 31. I put the value. Let me hit the enter. So this is here. It's showing the conversation complete is with complete data 31, which we have put the filter. And this is the connection got started with the port is. So this you can see that source port is a 67 60728, and destination port is a 23, telnet port 23, and this is the conversion took place. In all of the packet we will found the same source port and destination port. Okay, with the help of this we can put the filter for the successful connection. What are the flags we require?